Okay, welcome to Sa Majesty Easy World Science Channel. Today I will handle this immediately concluded NECO Practical Chemistry 2022. So over here we will face the quantitative analysis. First of all, we are told that all burette readings, initial, you see the grammar there. What matters is that we are going to pick our points here that A is a solution containing 0.15 mole per dm cube HNO3. Then B is containing 4.20 gram per dm cube. So this is the thing. But the weakness I discovered here is that when they were giving teacher's guide on the HNO3, they just say 9.50. They did not specify the percentage. So your own might not be up to 0.15. For example, if you have that 65% own, it might not be up to, which is a weakness. I suggest that when people gather for this marking, NECO should be corrected that while giving a volume of an acid, they should also give the percentage concentration. Is it 70 or 90 or 65% or 80%? It's very necessary because this thing they quoted here, your own might not be up to 0.15. But let's go with what they gave us and forget about the argument. So then B is a solution containing 4.20 gram per dm cube X 2CO3. Here they are all standard solutions, only that they heated the base. Now one of the applications of titration is to calculate relative atomic masses of metals or in a given salt. So after everything, normal grammar, you either use 20 or 25 cm cube portions of B. Then here I'm going to be using 25.00 cm cube as the volume of pipette. Then the indicator they say should be methyl orange, like I told you in my guide. Then here we got maybe your rough, we take it that your rough might be 15.70 all in cm cube. Then first titer, I'm using the one I got, is 14.50. If you use 13, even depending on, just make sure that you and your students rhyme or you and your teacher rhyme. Don't vary with more than 0.2 from what your teacher fill in the report form. So you accurately do your titration. The second one I got 14.40, and the other one is 14.60. Then where my initial is still 0.00, 0.00, 0.00, 0.00, such that I'll bring down rough is 15.70, 14.50, 14.40, and 14.60. So in this case, you are done with filling of the table. You come down here, they say calculate the average volume of A used. So in calculation of the average volume of A used, you now say that the average volume of A used, you tell the marker the one we are using. According to this table, first, second, and third are all concordant. You now just say you are going to sum up first plus second plus third, or you write 1 plus 2 plus 3 divided by 3, which includes you sum 14.50 plus 14.40 plus 14.60 all over 3. So at the end, what will you get? You are going to get check my calculator here. Okay, 14.5 plus 14.4 plus 14.6 is 43. Have 43.5 divided by 3. If you divide it by 3, you get 14.5. So 14.5 cm cube, or you say 14.50 cm cube, is our final answer here. Then coming over to the subsequent questions that follows, they said the equation of the reaction. They gave us the equation of the reaction. Then from the result and the information provided, calculate the concentration of B in mole per dm cube. And what did they tell us? If you are asked this question, you go and lift the information about B. B was said to contain 4.20 gram per dm cube of X2CO3. So in this case, you cannot use molarity is equal to mass control over molar mass, because the molar mass here is unknown. This X is hidden. Therefore, you are going to use CAVA all over CBVB equals NA over NB, where your Ca is the concentration of acid, which was given as 0.15. Your Va is the average volume of acid, which I got mine as 14.5. Remember, it's not a must to use 14.5. Then it depends on what your school teacher filled in the practical report. Then divide it by the concentration of the base is what we are looking for. That's the mole per dm cube, Cb, times volume of base is the volume of pipette, which is equal to 2 over 1. Mole ratio of acid, according to this equation, is 2. Mole ratio of base is 1 here. Therefore, we are battling with that Cb is equal to 0.15 times 14.5 of course, divide by, you cross multiply, divide by 25 times 2. You can even say this times 1, which is still the same. So at the end, from the calculator department, we have that 0.15 times 14.5 is equal to 2.175 divided by 50, of course, which will give you 0.0435. But according to this, you are advised to leave it in two significant figures or two decimal places, because the concentration they gave us over here, they say 0.15. So you are going to obey this significant place. So we are going to use 0.04 because 3 is not up to half of 5. Therefore, our CB is approximately 0.04 mole per dm cube. Final answer. Then we proceed to the subsequent question, which says the molar mass of B. Molar mass of B, we are now going to use the relationship which says that mole per dm cube is equal to gram per dm cube all over gram per mole. In that case, you can now convert this, that molarity, which is equal to mole per dm cube, is equal to mass concentration all over molar mass. They are asking us molar mass, therefore molar mass should be made subject to the formula. Molar mass is equal to, I'm just solving this to show you workings, not that in the exam you solve all this in this space. Molar mass is now equal to, it's going to give us mass concentration all over molarity. And the mass concentration was given in the question. Mass concentration of B over here is 4.2. Then the mass concentration is 4.2, while the molarity is 0.04, which is what we now have. So 4.20 divided by 0.04, we'll have that 4.20 divided by 0.04 will give you 105. So in this case, 105 gram per mole is our final answer for the molar mass of B. So we turn to the next page and see the subsequent question. The next question that follows is, they say the value of X in XCO3. The value of X, remember that the molar mass of XCO3, which is B, is what we got as 105. Then, what is your X alone? You will be given in brackets that carbon is 12, is already provided for us over here. Over here, they told us that carbon is 12, nitrogen is 14. So this information is what we will now use here, such that 2x, because of the 2 times x, plus carbon is 12, oxygen is 16 times 3, equal to 105. Such that 2x is equal to 12 plus 16 times 3 is 48, which is 105. Then we have that 12 plus 48 should be 60, of course. So 2x, okay, this is plus, not equal to, please, plus. 2x is now equal to 105 minus 60, and 105 minus 60 is 45. 2x is equal to 45, such that x alone is equal to 45 divided by 2, which will give you 45 divided by 2 with 22.5, give you 22.5. This is your final answer. So the value of x is 22.5. This is where we have to take some corrections. Some will forge and make sure their endpoint rhyme to give them 23. That's not exactly what is happening here. The marker is following your steps. And another thing is that if you don't approximate this 0.0435, if you use it that way, it is going to give you something less than 22 self. You might even get 17 or even get 18. So, but that's if you did not approximate, you are not going to fail. That's not the problem, because some will struggle to make their own 23. How do you know it's 23? Because your teacher have told you it's sodium carbonate, which suppose not. So the closer one here is sodium. It shows that B is actually sodium carbonate 4. But I repeat, if you did not get 23, 22, if your own was even 20, it doesn't mean you fail, since your endpoint rhyme with that of your teacher. And again, you did not approximate. There is no rule that say you must approximate. If you use 0.0435, you will not get this 20. You will not even get 105. You get something like 90 around. And if you get 90, probably you will not get 20. You get something below 22. So that is it. So don't bother yourself trying to manipulate. The marker is following your steps very, very well. So use accurately the figures I was giving to you. Now, the following question now, the next question says, write 2 precautions taken in order to obtain accurate readings from the pipette. From the pipette, they said pipette, normally you have to take the lower meniscus in the pipette, then avoid air bubbles. So here you just say, number 1, avoid air bubbles while pipetting the base, then read the lower meniscus. That's avoid error due to parallax while reading the mark in the volumetric flask. So number 1 is that you have to remember, they said in the pipette, not the burette, avoid air bubbles while pipetting or sucking, but here we use pipetting while pipetting the base. Then avoid using broken pipettes. Yes, it's another precaution. Avoid the use of broken pipette. Then avoid error due to parallax or read at the lower meniscus. Take the reading of the pipette at lower meniscus. Take pipette reading at lower meniscus or bottom of the meniscus. So there are other ones. Then what will be the color of the indicator in solution B at the end point? Color of the indicator in solution B at end point in B is yellow, but at end point is supposed to be orange or very pale pink. So you can choose any of them. The color should be orange or pale pink. So it depends on the concentration. If it is concentrated, it will be orange. If the concentration of the indicator is low, it will get you to orange at endpoint. But when there is low concentration of the methyl orange, you get very pale pink at endpoint. Red means you have added excess acid. So now that is it. We now come to salt analysis. In the salt analysis, they were provided. They say candidates are advised to adhere strictly to the instructions given, like I told you in my guide.
Hi, my name is Cheryl.
And I'm Jennifer.
Guess what? There's a channel called Some Majesty Easy World Science.
And you know the best part? It makes science so easy. Wow.
It makes science easy, simplified, and very, very fun.
Guess what? Rocket science ain't rocket science anymore.
It's now ABC.
Like if you did science your entire life.
Another thing about Some Majesty Easy World Science channel is that he makes available laboratory equipment and reagents.
Guess the best part? If chemistry has been hard for you, he does tutorials.
And another thing is, when you order for these things, they are high quality and they are also cheap and affordable for anybody.
If you want to order, just look at the number below the screen.
And don't forget to subscribe and hit the little notification button down below.
Don't forget to share, of course, obviously there's love in sharing.
Thank you! See you there.
Follow the instructions. You are provided with X and Y. They told us put a little portion of sample X. X is actually zinc carbonate and Y is actually aluminum chloride. So X is zinc carbonate, but you are not required to write this thing in your paper in exam because nobody told you this. But I'm saying it so that you can know where we are heading to in this class as it progresses. Remember, this is Her Majesty's World Science Channel. Please don't forget to subscribe and share my videos. I cannot do without you. Much love from me to you. Let us expand this science community. For more and more things will be coming from me. Stay close. So they say put little portion of sample X into test tube and heat. Test gas or gases that may evolve. I'm sorry for my followers that this escaped my memory, even though when I was producing the carbonate, to dry it became a problem. I decided to use heating. Then I stopped using strong heating because I discovered that on heating it turned yellow, but I never knew they would ask us this. But that makes it exam, of course. That is why you should have the correct sample. Most of you that don't have the correct sample and you don't have the way to tell your students, which is the normal thing, you're supposed not to communicate with the student, your student will fail. But for me, I'll teach them. In case anything I did not teach you come out, go and do the experiment. So I made my zinc carbonate, of which I supplied to some of you. So in this case, they say put little portion of X into a tube and heat. Test tube. If you heat it, they didn't say strong, just heat. There will be evolution of colorless, odorless gas, which turns lime water milky. Colorless, odorless gas evolved. colorless, odorless gas evolved gas turned lime water milky. What's your inference? CO2 gas from CO3 2 minus. Then the second one says heat the portion strongly in AI above. That is, after just heating gently, you are now asked to heat strongly. Heating zinc carbonate strongly to give you yellow. So your observation is yellow when hot and white when cold. That's the reality. Yellow when hot and white when cold. So what should be your inference? Zinc oxide present. Zinc oxide is the oxide that is yellow when heated and then white when cold. There is another oxide that is yellow when hot and also when cold, and that should be lead 2 oxide probably. So that one should be both yellow when cold and also yellow when hot, or maybe reddish. But zinc oxide is yellow when hot but white when cold. Then dissolve sample of Y in about 5 cm cube of distilled water and shake thoroughly. Divide the solution into 2 portions. Your job here is that you just say that Y dissolves to form a clear solution. To form a clear solution. So what is your inference? Y is soluble in water. Then to the first portion, add sodium hydroxide in drops. In drops, you just say white gelatinous precipitate. White gelatinous precipitate. I'm using pencil to fill this, believing you can hear what I'm saying. Okay. I didn't know the camera is not getting the inference, but thank God you see it. Now, the first one I say colorless, odorless gas evolved. Gas turned lime water milky. Or you can say even the same way the gas turned blue litmus paper red. But this milky color from lime water is the best thing that confirms CO2. So CO2 gas from CO3 2 minus. Then yellow when hot and white when cold. Zinc oxide present. Then the other one say Y dissolves to form a clear solution. This is clear solution. Y is soluble in water. Then when you add few drops of sodium hydroxide in the solution from B above, you get white gelatinous precipitate. You can write PPT or write precipitate. White gelatinous precipitate. Then if anything forms white gelatinous precipitate with sodium hydroxide, normally you should suspect aluminium or zinc present. You must write present. I told you in the guide. Now I've realized that the exam bodies have taken note of this because I don't want to argue alone. Initially, they do include a lead, but lead is chalky or powdery. Please, when it is gelatinous, you can't put lead again, so it should be aluminium and also or zinc. You can't even put calcium because calcium is powdery. Also, calcium gives powdery precipitate. But I think from my experience, I think magnesium also gives gelatinous but persists in excess. Then in excess of the sodium hydroxide, what happens? You write precipitate dissolves. Precipitate dissolves. So here they said 1 mark. I don't know what they have in mind. If precipitate dissolve, you can also aluminium present. You will still say aluminium ion or zinc ion still present, because these two will behave the same way with sodium hydroxide. Then we come down here. They say to the second portion from the B, that's second portion of solution of Y, you add dilute aqueous ammonia in drops. You write the same thing here. White, that is what is obtained. White gelatinous precipitate formed. Then if it is still white gelatinous in ammonia, you still write aluminium or zinc present. Then in excess, precipitate will persist, unlike here where it dissolves. So you write precipitate remained insoluble or persist in excess. Remained insoluble in excess. So what's your inference? Aluminium confirmed. This is enough to confirm aluminium ion. Aluminium confirmed, because if it were to be zinc, zinc would dissolve in excess of aqueous ammonia. But since it persists in excess or remained insoluble in excess, you write aluminum ion confirmed is enough for the confirmation. So this is it for the salt analysis. We move quickly also to the like other question number 3, random chemistry question. So over here we have, they said, what is the effect of adding sodium chloride crystal on the boiling point of water? The effect is that it will increase the boiling point, it will elevate the boiling point, or it will increase the boiling point of water. This is what we call colligative properties. They are actually properties that depends on the concentration or on the presence of the solute, not the nature of the solute. So impurities increases boiling point and lowers melting point. That is boiling point elevation and freezing or melting point depression or lowering of vapor pressure. So it should be a bigger topic called colligative properties. Then mention one characteristics of boiling. There are many characteristics. The only thing is that for a liquid to boil, the vapor pressure of the liquid must be equal to the atmospheric pressure before boiling will occur. So, and again, boiling occurs when a substance is heated to the boiling point, and boiling is also affected by impurity. So number 1 here you can write boiling occurs when the vapor pressure of the liquid is equal to the surrounding atmospheric pressure. That's the characteristic of boiling. Then any substance boils when heated up to the boiling point. Boiling occurs when substances are heated up to their boiling point. So boiling occurs when substances are heated up to their boiling point, which means boiling must occur at a particular temperature if all things being equal without impurity. You can also say boiling is affected by impurities. Then give one reason why the saturated solution of sodium hydroxide why the standard solution, not saturated, please, standard solution of sodium hydroxide cannot be prepared by weighing out accurately a given mass of solid salt and make it up to the required volume of solution. There is a contradiction here. Sodium hydroxide is never a salt. NECO should take note of this. How can you say sodium hydroxide and say salt? Sodium hydroxide is a base. For those that go for, I don't know what you call it, the gathering, I forgot that term we use. Normally, nobody is perfect. So, sodium hydroxide cannot be prepared by measuring given mass of the solid base, not solid salt, and make it up to the required volume. Simple. Sodium because sodium hydroxide is a deliquescent. Deliquescent. I'm finding this spelling problem here. Because sodium hydroxide is a deliquescent, that is, it absorbs moisture enough to form solution, which means to measure the mass accurately, it will absorb moisture and add to the mass, such that the readings, the mass on the weighing balance should be fake because water is contributing also. Simple, because sodium hydroxide is a deliquescent. Then the next one says, name one reagent that can be used in the laboratory for drying ammonia gas. You write quicklime. Just here is quicklime or calcium oxide. They say name one laboratory reagent for testing for water. You can use anhydrous cobalt 2 chloride or use anhydrous copper 2 tetrasulfate 6, that is white. Then, or you can use blue cobalt 2 chloride, cobalt 2 chloride pepper. You watch where I produce this pepper on my channel to know how to make it. So in the presence of water, anhydrous copper 2 tetrasulfate 6 turns blue but is white, but in the presence of water, blue cobalt 2 chloride pepper turns pink. So these are the two reagents you can use, or just say, without using the pepper, you can say anhydrous blue cobalt 2 chloride if they said not pepper, because some might argue that pepper is not reagent. Then Name one gas that cannot be prepared in open laboratory. Just any poisonous gas. Those gases prepared using the fume cupboard. We need hydrogen sulfide, SO2, even chlorine gas. Any of these gases are not advised to be prepared in an open laboratory. Even HCl, it fumes. These gases, carbon 4 sulfide, these gases are actually required to be prepared in a fume cupboard. So any of this is correct. Hydrogen sulfide, sulfur dioxide, chlorine gas, they are not required to be prepared in an open laboratory. Why? Because they are poisonous gases. Then give one use of each of the following apparatus in the laboratory. Separating funnel. It is used to separate two or more immiscible, not immixable, immiscible liquids. They're with different densities, of course, like kerosene and water. You can also watch my video here where I use the separating funnel to separate mixture of paraffin and water, kerosene and water. Then one use of gas jar. Gas jar is used to collect and store gas for collection and the storage of gases in the laboratory. Then I think that concludes it for the NECO 2022. So it's nice having someone like you. God bless you, and don't forget to subscribe and share. Much love from me to you. Remain majestic.
I'm Dr. Kingston, a product of Sir Majesty Easy World. Join Sir Majesty Easy World today and be proud of what your tomorrow may be. Thank you and remain blessed.
Wait a minute, have you heard about Sir Majesty Easy World? Well, I'm a subscriber to at Sir Majesty Easy World on YouTube, and I'm a student at University of Camerino, Italy. Sir Majesty made science so easy for me, and it took away the fear I had on chemistry and biology. Distance is not the barrier. Guys, you have to join the Easy World today at www.easyworldscience.com and on YouTube at Sir Majesty Easy World. Bye. Thank me later.